So, let's we are discussing about the algebra of derivative, and what we have seen is that if two function differentiable, you take their addition, take their multiplication, multiply it by scalar. If g is not equal to 0, then you define it f by g we can define, and that is also differentiable. So, what we have seen is that x to the power n this is differentiable, and the derivative is going to be n times x to the power n minus of 1. So, once x to the power n for n greater or equal to 0 is differentiable, therefore, any polynomial this is going to be differentiable, because the polynomial will look like what? P of x equal to a 0 plus a 1 of x plus a 2 of x plus a n x to the power n for some n. Now, all these are differentiable. So, what is going to be the derivative of the constant? The a 0 is constant. The constant we know that the derivative is going to be equal to 0, because f of x is equal to c. If let us say a 0, then f of x plus h minus of f of x divided by h for any h not equal to 0, this is going to be a 0 minus of a 0 by h, and this is equal to 0. So, therefore, for any h not equal to 0, this is 0, therefore, h limit h goes to 0 is going to be 0. Now, everything is differentiable. So, x to the power n is differentiable, this is a 2 x square, and the scalar a 1 multiplied to x to the power k, that is also differentiable. Then addition is differentiable, therefore, every polynomials they are differentiable. Now, if you look at the rational function r of x, which is equal to p x by q x, where both p and q are polynomials, and this we know that we have to take little care in defining this. We understand that whenever we are talking about the rational function, then q of x is not equal to 0. At those point I am talking about R x. So, now here p is as polynomial, this is differentiable. Suppose both p and q are differentiable at every point. So, because p is a polynomial, q is a polynomial. So, we have proved that every polynomials they are differentiable at every point. Now, whenever q x is not equal to 0 for those x, p x is differentiable, q x is differentiable. Therefore, R x, which is a rational function p x by q x, that is also going to be differentiable at that point, and we can calculate the derivative like this. So, now obviously, the way we have proved that the sin x is differentiable, you can prove that cos x is also differentiable. Now, once you prove that cos x is sin x and cos x is differentiable, then you can prove all trigonometric functions wherever they are defined. For example, tan x, where sin x by cos x, this is defined when x is not an odd multiple of pi by 2. So, now in all these points, wherever they are defined, tan x is going to be differentiable, because sin and cos both are differentiable. Similarly, for the cotangent function, secant function, cosecant function, all these trigonometric functions are differentiable wherever they are defined. So, this is now we have a pretty rich class examples of differentiable functions. Now, what we had earlier seen in terms of the continuity also is that if f is continuous at b and if limit g x goes to a is going to be b, and so if both, if f, what we have seen is that if f is continuous at g of a and g is continuous at a, then f composed of g is continuous at a. So, and in order to define the composition of two function, so we need to take care that the range of g is going to be inside the domain of f. Then only we can define f composed with g. Now, if g is a differentiable function of at x and f is a differentiable function at g of x, then the composite function f composed with g is differentiable at x. This is, and now the important thing is to find the derivative of f composed with g. Now, f composed with g prime of x, this is equal to f prime of g x, f is differentiable at g x. So, we can talk of f prime of g x times g prime of x, that is what. Now, let me give you a proof which is wrong, and but which is very intuitive, that this is the way one should like to approach. Now, let us take y equal to g of x, k equal to g of x plus h minus g of x. Now, you can see that y is a function of x and k is also a function of y is dependent on this h and k is a function of h. Now, so let us write down the Newtonian f composed with g of x plus h minus f composed with g of x divided by h. This is the Newtonian quotient what we are interested in, and we want to see that what will happen to this quotient when limit h goes to 0. So, this is f of g of x plus h and g of x plus y plus k. If you look at, then this is going to be g of x plus g of x plus h minus of g of x. This gets cancelled. So, this is f of g of x plus h, which is equal to f of y plus k. Now, minus f y, because g of x is equal to y, that is what we have taken, divided by h. As you can see that when h goes to 0 and g is a differentiable function at x, therefore, g is automatically continuous function at x. Therefore, g of x plus h minus of g of x, this is going to 0, because g of x plus h is go to g of x. So, if h goes to 0, then k also goes to 0. So, if I want to look at this, now this is equal to, I can write this, I will divide it by k and multiply it by k. Now, look at this one, f of y plus k minus of f of y divided by k. Now, k is g x plus h minus of g x by h. Now, g is differentiable at x. Therefore, this limit, this is going to be g prime of x. Now, f is differentiable. Therefore, as k goes to 0, this goes to f prime of y, f is differentiable at g of x. Therefore, this is going to give you f prime at, this is equal to f prime at g of x. So, this is f prime of g of x into g prime of x, then where is the mistake? Well, as you can see that here we can only divide by k provided my k is not equal to 0. And here there is a possibility in a neighborhood that our k of k can be equal to 0. So, this step I am not allowed to write. So, this is wrong. So, although the proof looks intuitive, but this is a wrong proof. Now, what is the correct proof then? So, we get the clue of this. So, instead of looking at k, we need to avoid this k can be 0. So, y as before. So, I am taking y to be g of x. So, define my phi of y, this is equal to f of y plus t minus f y by t minus of f prime of y, because f is differentiable at y, means at g of x, when t is not equal to 0. So, I do not know what happens when t equal to 0 yet. So, therefore, f of y minus t minus of f of y, this is equal to t times, this is equal to phi of t plus f prime y multiplied by t. Now, observe this, when t goes to 0, this one will go to f prime of y, this is f prime of y. So, if t is equal to 0, then this is going, we can safely define that this is phi of 0 is equal to 0, because as t goes to 0, phi t is going to be going to 0. Okay, so, now let us look at the Newtonian quotient f composed with g of x plus h minus f composed with g of x divided by h. Now, 1 by h I take it out. Now, here from this what we are going to get is that, you see, we cannot divide it by k, that is what is our problem. Now, here this what we have transferred by introducing the function phi is that this is f of y plus t minus of f of y. This is nothing but, if t equal to k, this k phi of k plus f prime of y, right. And now, this one k by h, this one will go to f prime of y, and then this is going to be f prime, I am sorry. So, this is going to be g prime of x, k of k is equal to g of x plus h minus of g of x. Now, this goes to g prime of x. Now, phi of k, as h goes to 0, k goes to 0, therefore, phi of k will go to 0. So, this first term is going to be 0, and the second term, which is equal to k by h into f prime of y, this will go to g prime of x into f prime of y, that is nothing but f prime of g x into g prime of y. So, here instead of one cleverly take care of this case. So, this proof now says that f composition of g prime of x equal to f prime of g x into g prime of x. Okay, so, now let us try to find the derivative of the exponential function. So, in general, what we define the exponential function is that the rate of the growth is proportional to the function, that is what is the exponential function is. So, now we define, one way of defining is also e to the power x, where this is f of x equal to e to the power x, which is to be the unique function which satisfies if I take the derivative which is equal to f. So, that is that for the time being, let us assume that. Now, if we grant me that, then if for any positive a, we have seen that we can define a to the power x. Now, then f of define f of x equal to, which is equal to a to the power x, then clearly a to the power x is nothing but e to the power x ln a. Ln is the logarithm with the base e. So, then this is, as you can see, is that it is a composition. Composition is here, the g of x is equal to x ln a, and f of x is equal to e to the power x. Now, f composed with g at x, which is equal to f of x ln a, which is equal to e to the power x ln a, and which is nothing but I am sorry, let us call this as h, then h composed with g is this. So, which is equal to f, your f of x. So, this f can be expressed as the composition of two function, and here this we are assuming it to be differentiable and the derivative is e to the power x, and here this is nothing but a polynomial x times ln a. So, h composed with g x is f of x. So, therefore, we are we can apply the chain rule. If we apply the chain rule, so this is equal to f, what we have shown is that f of x is h composed with g at x. Therefore, f prime of x, this is equal to h prime of g x into g prime of x. Now, h is e to the h of x is e to the power x. Therefore, what you are going to get is that the derivative is h prime of x ln a, g of x is equal to x ln a, and g prime of x is nothing but ln of a. So, this h prime e to the power h is e to the power x, therefore, h prime is e to the power x. So, this is e to the power x ln a into ln of a. Now, this is equal to a to the power x into ln a. So, here if you look at the exponential function, then you look at the slope at 0 of the exponential function, this is going to be nothing but ln of a. Now, slope of e to the power x at 0 is going to be 1, theta is going to be pi by 2, pi by 4. So, similarly, as an application of this chain rule, we can define for all positive real number, we can define the logarithm. Here I am taking the base to be e. So, you define f of x is equal to ln of x. Therefore, e to the power f of x is equal to x. So, therefore, let me define capital of f of x, which is equal to e to the power f of x. That what is going to give us that this is x, because if f of x is ln x. Now, the derivative, if I take e to the power f of x, then this derivative f prime of x, this is equal to derivative of e to the power x is what? This is the composition one. So, this is going to be e to the power f of x into f prime of x. And that is what it is. Now, the derivative on this side, on the right hand side, the capital of f of x, this we know that this is x, therefore, also we know that f prime of x equal to 1. So, what we get is that e to the power f of x into f prime of x is equal to 1. Thus, f prime of x, the derivative when f is the logarithm function, which is equal to 1 over x. So, with the chain rule, what we see is that the exponential functions are differentiable, logarithm functions are differentiable. Already we had seen polynomial rational functions and trigonometric functions, all these functions are differentiable functions. Okay, so some few more example. So let us take capital F of x, let us define to be e to the power sin x. Again, this is going to be, this is a composite function where you take f of x equal to e to the power x, g of x equal to sin x, then capital of f composed with g. Therefore, capital F prime of x is f prime of g x, which is equal to sin x, and g prime of x. Now, f prime, f is e to the power x. So, f prime of x is e to the power x. So, this is e to the power sin x into cos x. Similarly, another example what we can say is that you look at f of x equal to square root of x square plus 1. Then f prime of x. So, here you can say is that let us say h x is equal to square root of x and g is equal to x square plus 1. Therefore, our f of x is equal to h composed with g of x. Now, as you can see that this is defined for every x. Now, if we want to calculate f prime of x, then this is going to be h prime of g x into g prime of x. Now, h prime of x is what? H prime of x we have calculated is 1 by 2 square root of x. Therefore, h prime of g x is equal to 1 by 2 square root of x square plus 1. Now, this g x is x square plus 1. Now, g prime of x is going to be 2 x. So, this is going to be x by square root of x square plus 1. Now, let us see some application. Suppose a gas is pumped into a spherical balloon at a constant rate of 50 cubic centimeter per second. You have a spherical balloon, a gas is being pumped at the 50 cubic centimeters per second. Assume that the gas pressure remains constant and the balloon always has spherical shape. It maintains the spherical shape. Now, obviously, when you are giving the gas, the radius of the balloon will increase. Now, what one is supposed to know, we know that what pressure we are giving the air into the balloon and the radius is going to increase. Now, the question is that how fast the radius of the balloon increasing when the radius is 5 centimeters. Let us take r is the radius and v is the volume at the time t. So, we know that v is equal to 4 pi by 3 r cube. What we want to get is that so dr by dt what we want to find. So, because that is what the radius, how fast it is increasing, means we need to actually calculate dr by dt, that is what we want. Now, but now from this you see v is a volume is a function of time, r is also a function of time, with the time this is increasing. Now, this dv by dt, if I take the derivative, then this is going to be by the chain rule 4 pi by 3 into r is a function of t, therefore, 3 r square t in that's and derivative of dr by dt. So, this is what now what we know is that it is given that is the air is pumped with the constant rate of 50 cubic centimeter per second. So, 50 is equal to 4 by 5 and we are interested when r is 5 centimeter, that is 25 into dr by dt. Therefore, the radius is increasing at a rate of, so dr by dt is equal to 50 divided by 100 into pi, which is equal to 1 by 2 pi centimeter per second at the instant when the radius is equal to 5. So, thank you. This is all for today. In the next lecture, we will continue with our differentiation.